Hello everyone, welcome aboard. My name is Filipi Pires. Today we're going to talk about effective malware hunting in cloud environments. So I'd like to invite you during this day to talk with me about this topic to understand how it's critical when we talk about these malwares or these malwares in this environment called cloud, right? So let me share my screen with you now. Yes, perfect. I think you can see my screen here. So let me talk who am I. So it doesn't matter who am I. So here we have my contacts and social medias. If you'd like to send me a message, here my webpage, my Twitter, and my GitHub, and my LinkedIn. Just if you'd like to send me a message, you exchange knowledge with me. I really appreciate. Right. So during these days, we are gonna invite you to talk about this kind of summary. So first of all, a simple definition about who is a threat or what is a threat, right? So after that, I'd like to explain more about the malware analysis to you. And I would like to talk about the responsibility about the security sharing, right? In the end of this presentation, I would like to bring you some information about the structure of the PDF and about the impact when we see some malware in this cloud environment, right? So in the end, some questions if we have a time to answer you, right? So first of all, I would like to bring you this definition. It's not my definition, right? This definition is based on this ISO, right? So threat is defined as a potential cause of an incident that may cause harm to the system and organization, right? It means exactly a software attack or a theft of intellectual property, or maybe theft, identity theft, or maybe a sabotage, right? So all those things, or information extortion, are example of the information security threats. It means all those things is related to a software. If you think maybe the app, when the beginning to building the app, you have a code. This code needs to be maybe compiled, or if this code is compiled, maybe can change to a binary or an application or some app for a mobile, so all those things is related to a software. In the end of the day, all those things is related to a threat, right? So I understand now what is a threat. So after that, I need to understand about this simple life cycle about what is malware analysis exactly. So the first step is to understand about this identification steps, because I don't know if malware is malicious or not, or if this maldoc is malicious or not. So I have malware, it's a malicious software, and maldoc is a malicious document, right? So after that, I can apply my method to use in this analysis, or I can use in statistical analysis or maybe dynamic analysis. And after that, I can produce a report. This report I can send to my manager, a coordinator, or whatever that you can need to send, because it's very important, because you can present this information to someone, of course, and after that you can improve something. What I can improve? I can improve my defenses mechanism. This is the key in the end of the day, because if you have your environment in a cloud environment, you need to apply some adjustments in some configurations, right? You need to improve your defenses mechanisms. Depend, of course, on what is the software that you have in your cloud environment, but it's very important. So when you execute this kind of analysis, you can apply all those things in these configurations, right? So after that, you can build in the cyber threat intelligence environment. Many times you can use different tools to automate this process, right? It's very interesting, because you can generate this kind of intelligence when you see about the known threats and about the unknown threats, independent of the environment, right? So, and after that, you can create this training in cyber resilience, because the threats are changed all the time, right? So, okay, next steps, I would like to explain basically information about the statistical analysis. It's very simple. Usually it's the first step in malware study. Why? Because statistical analysis describes the process of analyzing a program code, or maybe a structure to determine its function, or maybe if you find some DLL, call some function inside of system operation. So usually this analysis, the program itself doesn't run at the time. Of course, depending of the program, but usually it's more, the process is more safe, right? Because you aren't actually executing it, right? So that's the point here, because it's usually is the first step in the malware studies. On the other hand, you have the dynamic analysis. Dynamic analysis is based on solely or only on behavior and the interaction that the malware has with the software or the environment there that the malware is executed, right? So also known like a runtime analysis. You can see the difference between runtime analysis and no runtime runtime, right? So this is the difference, by the way. And of course, you can easily automate it. There are sites today that already perform this analysis, malicious artifacts, because you don't know if the software is malicious or not, right? You have just a sample. And you have many antivirus scanning when you put the sample inside of this environment, and you can run this malware or the software or the sample, right, inside of this environment. And after that, you can see the behavior, because in this antivirus scanning, you have many engines provided by security sensors inside of this website, and you can see if these engines detect the environment, right? But you can create your own environment. You can call this environment the name and sandbox, right? When you have some virtual machine, or have some virtual machine in a controlled environment, you can pick up the sample, and you can execute this sample inside of this sandbox, right? So the another point is I would like to talk about the shared security responsibility, right? Because when we talk about the cloud environment, take a look at that. When you put your environment in the cloud environment, that's my point here. It's very important, because if you see, you have some difference when you apply your environment in this cloud environment. You have the customer data, you have the platform, applications, identity, and access management. You have an operation system, network, and firewall configurations. All those things is responsibility from the customers, right? So it's not my definition. It's defined by the cloud service provider. You know that? I think you know, maybe you know. I just put some cloud service provider here, like Amazon or Azure or VMware Cloud, but you have Oracle Cloud and another different cloud service provider. But we need to understand about that, because this step is very important. This is a security for a disaster provided by cloud service provider, right? Then of course we have some settings that you can apply in the cloud environment, right? But if you see in the environment, and for example in AWS, you have many different marketplaces to apply some using in the security sensor inside of this environment, right? So if you see, for example, marketplace from AWS, Azure, or Google Cloud, for example, in the marketplace, these cloud service providers recommend you to apply, a security sensor in your environment. So if the cloud service provider recommend you to apply security sensor, it means, of course, this responsibility is shared, right? So if you see in AWS, you can see this information, security measures that the cloud service provider implements in operation security of the cloud. It means here it's very important. While AWS manages security of the cloud, security in the cloud is the responsibility of the customers. It means you have this shared responsibility. It's very important, right? So if you see about the Azure, for example, shared responsibility in public cloud is related to a fact that you have a partner, right? When you host research on a public cloud service provider's infrastructure, who is responsible for what in terms of the security depends on cloud service model you use. In this case, IaaS, PaaS, and SaaS. It's very important. Again, it's not my definitions, right? It's definition from Azure. And before is definition for AWS. So you need to understand about these actually, because when you apply some security solutions or open source project, focus, of course, on security, you didn't look about that, right? Because it's very important. Not my, my definition, it's from the secure cloud service provider, right? So that's my point here. Okay, so we talk first about the threat, we talk about the malware analysis, and after that, we talk about the shared responsibility. So we have, you can imagine we have a cloud environment, perfect. So after that, so many times in the cloud environment, you have your applications, right? You have a server, you have, applications, or web applications or mobile applications, whatever. All those things are installed or in your cloud environment. Perfect. So I would like to talk about the one of the most common vulnerabilities called the file upload. It's very common. I would like to bring you this demo, explain more about this failure. So let's suppose that you have this application in your environment. Okay, it's a simple web, right, simple test. Okay, but let's suppose if you work or if you know some HR team, what is the routine of the HR team? The routine of the HR team is to receive a resume all day, right? You have the people from talent acquisition, the HR, the head of HR, the people receiving a resume, right, every day. So maybe some web application has this kind of space, not a space, but you can the candidate can upload the CV, the resume inside this application. So let's suppose that you have this. So another scenario. Let's suppose that you work with a financial company, or you are at the financial area, and probably you receive many invoices a day, right? So if you work with, if you receive some invoice, probably sometimes if you have some, program to use in your financial area, you have this browser to upload some invoice, so it's very common. I know when you look in this way, when you look, if you work with a security, when you look in this application, maybe it's very common to understand if maybe it's a suspicious or not, or it's dangerous or not. But if you work with a HR team, it's not a dangerous way because it's very common for you, right? So let's suppose about that. So this is the first example one. When you have these applications, the first idea, I will upload a simple code inside this environment. I create this shell.php, right? If you see here, it's a PHP script program, right? So it's very simple. I will call a simple PHP, and I set here the parameter to call get, and I set the variable CMD. So I try to upload my file inside of this environment and take a look what happened. Uploads done. Your file can be found here. So I can find the file here, the real path where this file it was uploaded. It's very dangerous because the attacker can use this to explore this vulnerability. So here I have the path, the exactly path that I have in the server, right? So let's suppose if you have this in your environment, your cloud environment, right? So the attacker can manipulate your environment. So let's see here. I set the parameter CMD, and I using the command injection. It's another vulnerability. So I can set here the many commands here because I execute my file inside the victim machine. So now I have a control of this server. So let's suppose I can execute others to try and see if I have connection with another server inside your cloud environment. I can see if I found some articles or some files there. And take a look here. I put example number 2. I upload the same file, but here I receive the answer no PHP. It's not possible, right? So probably we have some security applied or some definitions in the code, right? So take a look what I did here. I change the extension because this is the first idea, right? Because probably the application, it was based only in extension, right? So they don't have the good recommendations probably. apply it in these applications, right? So I try to upload this text, doc text, take a look at this, and when I try to send the file, take a look what happened, I got it, right? So now I have a control the same way the first example. I just change the extension from this file, you know? So here it's the point very, very important because I just changing the extension, yeah, I got access in the environment. So let me explain another thing here to you. Let me open here my virtual machine to you, and I would like to explain more about that, right? So do you remember when I explained about the malware analysis steps? We have the first step, right? Is the identification steps. I can use the file command to identify if this file is malicious or not, for example, Amazon. When I execute this, file run here, as you can see, and after that, I receive the return here. It's a word, right? So let me try looking this another file. It's invoice.pdf. It's a PDF. Perfect. Let me see another. Let me see. Okay, resume, because you know it's very common that I mentioned, right? It's another PDF. Okay, Filipe. Everything works well. Let me looking another here. Linux 64. Oh, this is a ELF. It's a binary executing in Unix platform, right? So executable. Okay. But let me see here this Linux doc text, right? So file Linux doc text. Take a look at that. It's not a text. It's a ELF, right? So take a look what is important to understand about that. But here it's the key. So, for example, how this command works. But before talk this command, let me return the presentations here. When we see the first example, let me explain here. As you can see here, the code is in Python, right? The Python, I'm sorry, in PHP. And here you can see the director where the file, it will be uploaded, as I mentioned, right? As you can see later when I present the demo, right? So here you don't have any parameter you can upload any or whatever file you want in this code. But here, as you can see, we have this function. So if the preg and the score match is just doc.php, it means just is if the attacker can use the doc.php, you can deny this information and you can print this no PHP, as we saw during this demo, right? So here it's important. This is the better situation, not a better situation as we see, because it's only defined in the extension, right? So the best choice maybe is to write the code based on in a magic number maybe, and I will explain now what is exactly magic number, right? So here, as you can see, the code is based on doc.php, right? So let me return here. I explain about the file, right? This is the command, but what is exactly this command file? File is exactly a tool that is determining file types. Okay, it's totally normal as we see here. So here, as you can see, file tests each argument in attempt to classify it. It means the file command basically in attempt to classify the file. Perfect, right? So here we have another very interesting information. It's very important to understand. But here we have the key. This file have a magic number, right? So as you can see here, stored where? In a particular place near the beginning of the file. So all those binaries or file has a magic number where stored in particular place near the beginning of the file. So here is important because as we saw in the code, the only check is based on extension. And as we see, we see some difference between this extension of the real binary, right? So I will try to explain more using some example with you. let me go here. This is the file, magic and mag.g. Here is the source code base of the file I download from the Debian, and I would like to explain more details about that to you, right? So here we see here all databases that are the file used in the Unix platform. Of course, when we use, if you see here, file man again, all those informations are here. Take a look here. Any file with some environment identifier at a small fixed offset, right, into the file can usually be described in this way. The information identifying this file is read, as you can see here, from etc magic, right, and compiled magic file. It means the file is the file command is compiled in this way, right, in this path actually. usr /share /misc /magic.mgc, right? So here is, but if you try see here is a compiled, it's empty, right? So, and here, as you can see, or the file in directory is in usr usr /share /misc /magic. If the compiled file does not exist here because it's compiled, as I mentioned. So in addition, I'll take a look at if home /docmagic.mgc or home.magic exist, will be used in a preference to system magic file. It means you can generate your own magic number. It's very interesting here. So as we see, the database is compiled in the Unix platform, right? So I download the real code just to show you how this works in a background, right? So let's see here how this works in a JavaScript, for example. JavaScript here. So here we have some not rules, but some yes, maybe rules that file a command using this database. So if the file, for example, beginning, do you remember, stored on the beginning? Let me copy this and let me try to do something like malicious. Let me nano malicious dot text. Perfect. Malware. Just run here. Let me save, and yes, let me use here malicious. Is a text, right? Is a ASCII text. Is a text file. Is I using cat to read. And malicious is a text. Perfect. But let me change again here. Take a look what happened here. Paste here. Okay. Let me save. Yes. Take a look what happened here. Malicious text is a node script, as you can see here, you know, because you have a key here in a variable. Let me change again. Let me delete here. Okay, let me save one more time. Let me see what happened. File, malicious again. Send script, you know. Cut JavaScript, because I would like to see to use the JavaScript. Here it's almost the same. It's a node, it's a line. We copy here. Let me change. I think it's the same. Oh no, not the same. It's a bin, right? It's a node, but another it's a bin. Because of this, we have a problem. So let me delete here and let me save. And yes, and now malicious. It's a Node.js script, right? So as you can see, I can manipulate the file. Let me manipulate one more time here. Let me cut here. I don't know if you are a programmer, but if you are a developer or programmer, you know what this means, right? So let me save here again. Take a look what happened here. File malicious. Now we have a Python script. Whoa. So, but it's a text. Let me change here malicious to malicious again. malicious.python. If you try execute using a Python 3, not 4, 3. It's impossible because it's not a Python script, right? Of course, we have here the word that I wrote, but it doesn't, it doesn't exist in the code, right? So one more time, and the last time that I will manipulate again the magic number. As you can see here, let me cut this, and I will put the %PDF. -1 and 2. I can save again, and yes, let's see what happened here. Malicious Python. It's not Python. It's a PDF, right? So you know how this works. I am manipulating the magic number, as you can see here. I just reading the PDF. Take a look at that. The string, right in the beginning, in the particular place in the beginning of the file. I am manipulating the file, right? So here is the key. If you're using just in an extension, we have a problem in your cloud environment, right? So let's return here what the attacker can do if the attacker explore your environment. So I explore here, you remember. So I set some commands here, ls, to list the directory. So now I am copy my IP address from my attacker machine. I using a netcat to open my port to gain the access remotely, right? So I'm using, by the way, here the port 443, right? Because I'm remotely from this this victim, right? So do you remember? You imagine if you're in your environment in a cloud and you have this, or your application and you have this port to open because you need to access this from the internet, right? And the attacker can try access your environment. Take a look what happened. I'm open to listen this port. I'm clicking enter and this server, and now I got access in the environment. I have a shell with this environment. As you can see here, I can see my shell here in PHP, my file. Do you remember that I uploaded in my victim machine? And now I have a control, and I can investigate this victim machine now. I have all those controls. I have an access. I have a control from the users, and after that, I can try access, for example, the real path of the environment. As you can see here, we have many others informations here and code. I can explore them and take a look what informations I found here. I am looking from I'm trying to see the real code to explain you. So this is the path in upload, and I try to show you the real example 1 or 2. I think I will explain the example 1 or 2 is a 2. Yes, because I would like to show this information here. No PHP. Do you remember? Based on the extension here, the code, the source code of the page of these applications, right? So it's very important to understand about that. So here I would like to explain more about the physical and logical structure in PDF, how the attacker can manipulate of this and using this to try attack the environment using, as I mentioned later, HR team or financial team, right? So basically we have the 4 mainly parts. It's header and body and cross-reference table or X table and trailer, right? So as you can see here, first of all, we have a header. In this header, we have an object, we have an information header, as I mentioned, right? So the version of the PDF, as you see, as you can find the magic number, right? And here we can find the body. Usually we have an image, pages, and something like that. Here we have a cross-reference table and trailer. All those is locations of the object within the file, but for random access, all those connected, referencing and themselves, right? So let me explain here another demo. Here I have basically a resume here. I received a resume and I try to investigate this resume, right? So, but I changed the name of the folder, the file. It's not a resume. I put sample, but it was a resume, right? And here we have a 15 object inside this resume, right? So inside of this resume, we have a 2 extreme, where is the place that attacker applied something malicious. Here we have at 5 JavaScript, and you have here, take a look at this, 1 open action. It means it's when you have this information inside of this PDF, it's basically when the victim receive the file and click to open the file, just to not open, to download the file. And when the user download the file itself execute itself in the victim machine. The user don't need to click to open the file, right? So the user received by mail, and after that, when the user download the file inside your environment, automatically the PDF is started itself in the victim machine, right? So this is the function, open action, or AA, right? So this is basically the function. And after that, I using these tools based on provided from the D.A. Stevens. It's a very guy of research. And after that, I using the PDF parser, another tool provided from the D.A. Stevens. I execute to try see about the run, right? The run data, and I can see here all those information. As you can see, the header, right? The magic number informations here, as we see. Object 1, and take a look what I'm seeing here. The object 1 referencing object 2, 3, 4, 5, 6, and 7, as we see now here. But we do remember we have a 15 object inside our environment. So we need to explore more this another object. And another important thing here, it's about the open action here. We have an open actions, call it using a JavaScript, So do you remember the open action? When the user receive the file and download the environment. After that, these functions will execute automatically. Do you remember? And these open actions will call a JavaScript, as we see, and I'm explaining you, right? Okay, let me return here. And we see many others information. Maybe you don't have a time to explain all those details, but I have another talks in other events in my webpage. We can find this talk that I am explaining all those details about the others object, right? But here is the key. In object 13, we contain one extreming. And this extreming has a length very, very bigger. It's not small, it's bigger. And this streaming has a flat decode technique. It means I need to decode this information because probably this streaming contains some techniques that I need to understand more, right? So, okay, I need to investigate and I need to use some tools to try find any information inside of this object 13, right? So here I have important information to find. Okay, so I will use here another tool, PDF TK, to looking more deeply for this PDF. So I execute the PDF TK sample, I generate the output, and of course in this output is wrote in the dump doc text, and the mainly function here is uncompress all those informations, right? So and after that I can have all those informations inside of this dump doc text uncompressed, right? So take a look what I found here in object 13. Do you remember this is a big length, a big size, and I have here the first technique that the attacker used in this attack, the JavaScript obfuscated, right? So here we have a JavaScript obfuscated. So I need to disobfuscate this JavaScript. And here we can see we have an evil parameter. So if I have some evil parameters in the beginning and the end of this file, I thought I can try to rewrite this file, and we are talking about the applications. So if I'm talking about the JavaScript is related to applications. I can try to open this information in some doc HTML, right? As I mentioned, I generate the payload doc HTML file, and I try to see if I, find some information. If you see here, we have a different green color. So, and another thing interesting in this code is the module, as you can see here. We have some standard module here, numbers, letters, and percent. number, letters, and percent. It's, you know, makes sense to me. Maybe something inside of this parentheses. You know, I don't know exactly, but when I saw that, when I made this investigation, it may make sense to me, right? So let's continue the demo, right? So I delete this eval parameter, and I using a document write to, you know, to write this information in a HTML page. That's my idea here, because I will try to obfuscate this code, right? So, okay, I save the file here, as you can see, and after that I can execute this file in a browser, right? So, but I need to give the permission to execute this file in a web browser, right? So, okay, I found the file with the JavaScript obfuscated inside that. So, but what is exactly inside of this JavaScript? Here we found the informations. We have a payload. You know what that means exactly? Payload is a part of the code responsible to downloading the victim machine. This code is responsible to make a callback to the server from the attacker. So do you imagine if you have your cloud environment, you receive some file. Let's suppose if your HR team received this file, and this file, it is downloaded in your server environment, and how this file has the open action. This open action execute this JavaScript. This JavaScript will execute the callback to the server, to the attacker, because they will download this payload inside of the victim machine, and this payload will call back to the server, to the attacker. Good. But you remember about the standard module that we have here? Not a module, it's standard, right? So some standard things, you know, letter and numbers and percent here. So, okay, I need to investigate more about that. So this is the next step that I did. So I copied this information, right? And I try to investigate more there. So first of all, I copied this information and I send to I return to my Linux platform and open this file called the real payload, because my idea to understand what I have inside of this percent and numbers and, you know, and letters. Then after that, I used sed to cut this percent. Like, you know, it means I clean the file, as you can see here, and I have here another thing interesting. Here we have another kind of technique, the encode technique that we have here. So here it's very interesting because it's all these techniques. It's a EC2 based on Unicode, because usually the people now using the ASCII based on 1 byte, or usually in a UTF-8 or something like that. But this technique, it's old in EC2 based on Unicode. So I generate the real Unicode. But okay, maybe you are thinking, okay, Filipi, you're just using a Unix platform, but I like to use a Windows platforms. No rules. You can use Mozilla by Bobby. It's another very interesting tool, because I copy the same code here, as you can see, percent, letters, and numbers, and I pass here. I use here the MISC decoders to cut this percent. It's the very similar behavior that I use in a sed, right? So after that, I using the MISC decoders to generate an exa file doc binary. Why I do that? It's very simple, because I think it's 90% of this attack it's the focus in a Windows platform, right? I don't know, if probably if you see some organization that it can have some research, maybe we have this information. It's my only opinion, because based on all the last attacks that we have in the world, right? So I generated this hexafile binary because if you remember, the victim machine, the victim can receive this PDF, and the victim can download this PDF inside of your environment. And after that, I generate this hexafile binary. As you can see, I using another platform provided from the J. Stevens, Shore Research Doc XC. and I call the binary hexafile.binary, and I call HTTP, because you remember the payload is responsible to make a callback to the server, to the attacker. So my idea here is to try and find, some any HTTP informations of inside of this exa file, and take a look what I found here. The IP from the attacker. This IP, it was on Estonia, where this, the main, where is the attacker is based, So here, if you have any question now, you can talk more about that. I finish here my presentation, and I really appreciate to stay with you here. And again, if you have some questions, guys, just to clarify, we have a cloud environment, many microservices, many companies create very fast, and you need to apply the best practices of this security in your cloud environment. And after that, you need to see about the security sensor. You need to apply this in your different, places, not because you need to understand about the architecture actually. And after that, you need to apply the correctly security sensor. And you need to understand, you need to talk about the security with your, users. And if you see these presentations, this victim receive a PDF file. Inside this PDF file, we have a JavaScript. You remember, this JavaScript has it was obfuscated, and the side of this JavaScript has a payload responsible to call back to the server, right, to the attacker. And after that, this callback using an EC2 based on Unicode, another technique to, to encode this code. Very complicated, but it's simple. In this code, we have IP from the attack, right? So we learned this about this attack and understand more about these details, right? So again, if you have any question, please let me know.